Myself, V. Kirtisri. I am from ECE department, PVIT University. Today, my topic is about logic gates. Basic logic operations. The use of switches, closed or open electrical paths, and light bulbs to illustrate the idea of logic variables and functions is convenient because of their familiarity and simplicity. The logic concepts that have been introduced are equally applicable to the electronic circuits used to process information in digital computers. With the help of transistors, it is possible to design simple electronic circuits that perform logic operations such as AND, OR, NOT, and XOR. It is customary to use the name gates, these logic gates. We have different types of logic gates. In that, the first one is NOT gate. It is also known as an inverter gate. NOT gate. NOT gate is a single in and single out logical device which the output will always be the complementary form of the input. This means that the output is 0 for input equals to 1 and vice versa as indicated by the truth table. This is symbolically written as y is equals to a bar. We saw that NOT gate is the complementary form of output when input is a. Here we taken that input a and output we gain that y is equals to a bar. In truth table we taken as if a is 0, the complementary of a becomes 1 and a is 1, the complementary of a becomes 0. The next gate is about AND gate. AND gate is a basic gate with multiple inputs and a simple output. The gate has its output high only if all its inputs are 1, following which the output will be 0 as shown by the truth table. The logic expression corresponding to the gate is given as y is equals to a dot b. It means the multiplication of two input gives the output. This is about AND gate. As we know that the input A and B are taken in AND gate, therefore the output becomes y. Y means y is equals to A dot B. It means multiplication of two inputs. In truth table, we see that the A value is taken as 0 and B value is taken as 0. In my output y is equals to A dot B. 0 dot 0 equals to 0. And input 0, A0, B1, 0 dot 1 equals to 0. If input A1 and B0, 1 dot 0 equals to also 0. And if inputs A1, B1, 1 dot 1 is equals to 1. It means if only the two input becomes 1, then the output becomes 1. OR gate. OR gate is a type of basic gate with multiple input, single output characteristics. It means we give multiple number of inputs, but the output will becomes only a single input. Here the output is 0 only if all of its input bits are 0. It means the input of every bit is 0, then only the output will become 0. The logical expression for the OR gate is given as y is equals to a plus b. As we see that the input A and B are passing through OR gate, the output y. The output y becomes a plus b. It means how many inputs are given to OR gate, the single input comes out from the OR gate. Here input A is taken as 0, B is taken as 0, then output becomes 0. Only when the inputs, all of the inputs taken 0, then only the output becomes 0. Here input 0 and 1. It means A0 and B1. The OR gate y is equals to a plus b is taken as 0 plus 1 is equals to 1. For A1 and B0, 1 plus 0 will also becomes 1. For input A1 and B1, sum 0 and carry becomes 1. This is about OR gate. AND gate. NAND gate is logically equivalent to AND gate followed by a NOT gate. It means the combination of two gates. AND gate and NOT gate. The truth table for this gate shows the output of NAND gate is low only if all of its inputs are high, else it is 1. It means if all of its inputs is 1, then only the output becomes 0. This implies that the output of the NAND gate is negated output of the AND gate. It means purely opposite to AND gate, represented by the intermediate result M. In the above truth table, logical expression for NAND gate is taken as y is equals to a dot b whole complement. As we saw that y is equals to a dot b bar is the output form of the NAND gate. It means input a and b is taken to combination of AND gate and NOT gate. Combination of AND gate and NOT gate, we get y is equals to a dot b whole bar. It means whole complement. Here the inputs are taken as A0, B0, then the output becomes A dot B. It means 0 dot 0 whole complement is equals to 1. Here the input is taken as 0 and 1. It means 0 dot 1 equals to 0. 0 complement becomes 1. Here the input is taken at 1 comma 0. 1 dot 0 becomes 0. 0 complement becomes 1. Here the inputs are taken as 1 dot 1. 1 dot 1 becomes 1. 1 complement becomes 0. NOR gate. NOR gate is a result of combination of NOT gate with an OR gate. It means it is combination of two gates which are OR gate and NOT gate. This is output is the negotiation of OR gate output, which implies that it has high output only if all of its inputs are low. It means it is some opposite to OR gate. However, for any other combination of inputs, the output will be low as shown by the truth table. The logical expression for the same can be given as y is equals to a plus b whole bar. It means whole complement. As we saw that NOT gate is the combination of OR gate and NOT gate. It means OR NOT. Output becomes y is equals to a plus b whole complement. If we take in the inputs A0, B0, then the output becomes 0 plus 0, 0. 0 complement is 1. As A0, B1, 1 plus 0, 1. 1 complement 0. As A1, B0, 1 plus 0, 1, and 1 complement is also 0. As we take in A, B, 1 and 1, 1 plus 1 is some 0 carry 1, but the complementary form is 0. This is the truth table and gate diagram of NOR gate. XOR gate. XOR gate is also known as OR gate. XOR gate is a logical device which has its output high only when its inputs are having odd number of ones, as shown by the truth table. It means the inputs have odd number of ones, so that's why it is also known as OR gate. This means the non-identical inputs results in high output of the gate, while identical input bits cause the gate output to go to low. Logically, this is given as y is equals to A XOR of B. Further, in this expanded form, gets y is equals to A complement dot B plus A dot B complement. In general, XOR gate is used as parity checker and can have multiple inputs. This is the gate diagram of XOR gate. When inputs A and B are passes through XOR gate, output Y becomes A XOR B. It means in inputs A and B are taken as 0 and 0, output Y becomes 0. Input A0, B1, the odd number of ones, so that the output becomes 1. Input A1, B0, odd number of ones, it means output Y becomes 1. Input A1 and B1, it is even number of ones, so that the output Y becomes 0. This is about XOR gate. XNOR gate. It is also known as even gate. XOR is known as OR gate and XNOR is known as even gate. XNOR gate is a result of combination of XOR gate with a NOT gate, which means that the output will be inverted form of the XOR outputs. Its output high only when its input are having even number of ones. As shown by the truth table, this means the identical input bits result in the high output of the gate, while non-identical input bits cause the gate output to go to low. Logical expression for the XNOR gate is given as y is equals to a XNOR of b. It means it also taken as a dot b plus a complement dot b complement. This gate can also have multiple inputs, serves as a parity checker. So this is the XNOR gate. XNOR gate is the combination of XOR gate and NOT gate. Y is equals to a XNOR of b whole complement. It is also known as a dot b plus a complement dot b complement. In truth table, here a taken 0 and b taken 0. Even number of means, it means 0 number of 1. So output becomes 1. Here A0, B1, odd number of 1, so output becomes 0. Here A1, B0, odd number of 1, so output becomes 0. And A1, B1, even number of 1, so output becomes 1. So this is about the logic gates. Thank you everyone.